Right.
No swearing, Tom, video's on.
I'm gonna edit this one, obviously. Alright. So 5th grade team, our standard we're focused on today, I can solve word problems involving multiplication of mixed numbers in an area context. Students completed the checkpoint C. So as we're looking at student work today, which questions did you find that your students were the most successful with?
Definitely problem 1 for my kids. Using kind of multiplication as scaling. Knowing that when they're multiplying a whole number by a fraction less than 1, they're gonna get a product that's less than that whole number. If they're multiplying by a fraction greater than 1, they're gonna get a product greater than that whole number, and then a fraction equal to 1, they're gonna get a product equal to that whole number. Most of my kids, every single one of them, correct, so they did great on that.
Did you guys have your kids show work for that one by solving or just use the number sense?
No, number sense. I told them solving would be a strategy if they didn't understand the number sense part of it, yeah.
I did have a few who did on their own, wrote out all the problems. So, I did have one, the last one, the 5/5 times 4, I had a couple of kids who picked that. I don't know if we're getting into the trouble spots with it, but
Yeah.
that's the only issue that we had along the way, is a few kids picked the equal to, instead of just greater than. So we talked about that
And I had
after
one,
the fact.
do the same thing, but they showed their work as 20. So just a quick misconception, 5/5 is 1, and then they were fine.
How did problem 2 go?
That was the most missed one for me.
So what was the big misconception, or was it the question that the students you think struggled with based on the work they showed you?
They, for me, a lot of them did it as a subtraction problem.
Subtraction, yeah.
And we talked, at length, the first time we did all this, every time we've seen this, of the flour means that it's gonna be a multiplication and not subtraction. And if they said that she used 3/4 of a cup, and we went through all of that type of stuff, and we do it every time with problems like that, and it still is something that they struggle with.
Yeah.
Same thing, and I think asking the question at the end, if this would have been subtraction, what would they have asked at the end?
Right.
How much is remaining, how much is left? But that was the same thing for us. The other thing that we have issues with is the students are missing this because they know it's multiplying, but they're not applying the methods that we've been teaching. So they're trying to distribute both factors, or they're not converting to an improper fraction. So that was the most missed for me as well.
Yeah, same. It was either a subtraction problem, or they were trying to cram it all into this tiny little space, and their handwriting is a mess, so they can't read their numbers, so then they're multiplying wrong. So my kids that got it wrong, that showed like the area model, I didn't even say anything. I just handed the paper back and said, read your number 2 on the back where you have more space. All of them came back to me with the correct answer. So this graph right here, I don't like, because they're having to break this little tiny piece into fourths, and then it's kind of a mess. So I told my kids just to draw their little simple area models.
Did you model one for us?
Sure.
See if
So 4 and a
everyone
half,
agrees.
4.5 times 3/4.
Yeah. So when reteaching, for those that missed it, you would show them this? How to draw it this way?
Yep, well, this is the way I've been teaching it the whole time. So we decompose the 4.5, break it apart there, we're gonna multiply it by 3/4. So we're finding the area of this box, which would be 4 times 3/4. They would multiply that to get 12/4, turn that into 3 wholes. And then this box would be our 1/2 times 3/4 to get 3/8. And then they're just adding the 3 plus 3/8. tell my kids, this is the simple diagram versus them cutting,
The graph
yeah.
paper.
Yeah.
So maybe next time when we do this, we white that out, so then kids can just make the way you taught it. Good. Any other strategies for problem 2? As far as like the wording part of it, how do you, I know you were practicing it in class, but how would you reteach that group of kids who are not getting that language of the flour to bake cookies?
So what I did after, seeing the results was, I said, let's say that Jennifer had 100 cups of flour and she used half of it to bake the cookies. Like, how much would she have used? And they all said 50. Well, okay, why is it 99 and a half? Because that's what you all, and then,
Yeah.
wait a second.
Yeah.
So they get that when the numbers are easy to
Easy.
work with, they have no problem. It's when the fraction part comes in that they start to get, this doesn't make sense.
And then problem 3, any celebrations or misconceptions?
So for this problem, I'll be honest, my morning block, I just handed it out. And the one thing we continue to say not to do is multiply the whole number by the whole number and the fraction by the fraction, which gives you choice A. 12 kids chose that. It was an alarm for me personally, went off. The afternoon block, all I simply showed them was a quick line plot on the board of the number of kids that missed number 3. And I didn't say anything else. I just said, look at how many kids missed number 3, and then I handed it out to them. The blocks are different, so I would have expected block 2 to do better, but 0 kids made that same error. The correct answer is D for this one, but it's just constantly reminding kids that you can't do that. You have to either convert to improper fractions, or you can show a nice big area model. And the area model is a great way to show it because it'll also show why it's not choice A. Because the 16 and the 3/12 will pop out, but it also shows them it's not enough of the area.
Yeah, my kids who got this wrong did not do the area model, and again, I took my paper back and go do number 3 using the area model.
And they got it right.
Yeah. So I think it's them slowing down, taking their time, because they want to use the distributed property, but they're not using it correctly. But the area model forces them to use it correctly. And then there was a lot of, where they're having to find equivalent fractions to do the addition part. Not a lot, sorry, there's only 2 of them. They end up with 2/3 and 3/12, so if they're having a hard time finding equivalent fractions, they would definitely struggle with adding them together.
And it wasn't the case with this one, but it could have been because of the numbers that they chose, but like, 'cause they had 4ths and 3rds, so you have 3rds and 12ths, but you could have also had 4ths, which are not in the same fraction family. But we talked about that on a couple other problems, how they're cousins, they might not be in the same like immediate family, but I can turn both 3rds and 4ths into 12ths, so that kind of works, and that happens with halves get into there, so it's halves, 3rds, and 12ths that we kind of say, like, well, you can turn both 3rds and halves into 12ths. So we just, instead of the fraction family, we just say that they're cousins, and then you don't have to change both of the, if you got the 3 different things that you're having to convert to.
The last thing I've been working with kids on, and I was curious what your takes are on this. When your mixed numbers are such large numbers, or if your denominators are gonna give you more than 12, you're left with improper fractions where you have to multiply larger numbers, divide by larger numbers. So we're having this talk about, what do you think is easier for you? And I continue to tell them it's dependent on the problem. Like, don't say to yourself, I'm only an improper fraction student, I'm only gonna convert these, because you're actually doing more work if you were to show the area model. Whereas if the numbers are very small, the mixed numbers,
Like 1.5 times 2 1/3.
improper fractions is a quick, easy way where you won't have to make your denominators the same at the end. So like having these like discussions with kids, and then each day saying which one's easier for you, it's been good for some kids to diversify a little bit and say, I can do both. Like, that's my
Yeah.
goal, is for them to be able to look at a problem and say, this one's gonna be easier to use this way.
My higher kids are the ones tending to use improper fractions, so the other day, I had 2 kids race, to show them that the area model was a little more efficient than using improper fractions.
Okay.
And sure enough, my area model was faster, cause they had to convert, they had a way bigger number on top than
Yeah.
they did for the denominator, so they were stuck doing the division where the other person was not, so.
Right,
Yeah.
so like that problem ends up being what, 275 twelfths or whatever,
Yeah.
and then they got it.
Okay,
And that was actually kind of an easier one, cause sometimes you get like, you know,
Yeah.
274,
Right?
23rd, or no,
Right,
not
yeah,
23rd,
yeah,
but-
Awesome. All right, so, sounds like a lot of you did reteaching in the moment. So, and fix those strategies, so prepping for the end of unit test, just kind of more practice with these types of strategies. Awesome. Thank you for letting me video you all.